Hi everyone, let's graph this piecewise function. And remember that function values correspond to y coordinates. Now this graph will have two pieces to it, although they could connect at x equals 1. We'll see. So we're going to look at the unrestricted graphs that correspond to these rules. We're going to see where the left endpoints are, and we're going to see where the right endpoints are, if any. Bear in mind that if we have something like this as a subdomain, there is no left endpoint. And if we have something like x is greater than 1, there is no right endpoint. But it does turn out that in this particular example, that both of these subdomains do each have two endpoints, and therefore the corresponding pieces of graphs, these two pieces here, will both have two endpoints, a left endpoint and a right endpoint. So we're going to fill in all four of these spaces. Again, sometimes you don't have a left endpoint, sometimes you don't have a right endpoint. But here we do get a left and a right endpoint for both pieces. Okay, so first off, let's consider the unrestricted graphs for these. How do you graph y equals x squared? Just a quick sketch. You don't have to be too accurate with this. Y equals x squared, that's going to be a parabola whose turning point, whose vertex, is at the origin. And how do you graph y equals x plus 1? You should know that from section 0.14 on lines. This was back in 1.3 on the gallery of graphs up here. This is from 1.3, the gallery of graphs. And here, this is from 0.14 on lines. Y equals x plus 1. Y equals mx plus b. That's going to be a slanted line of slope 1, whose y-intercept is at 0, 1. Again, just quick sketches. Now on Desmos, we could graph y equals x squared and y equals x plus 1. And are we done? Is this the graph of our piecewise function? No. The answer is a big no. For one thing, the red and blue graphs together are going to fail what test? Massively. The VLT, or the vertical line test. If you offer this as your graph of f, this is way wrong because it's going to fail the vertical line test. That means that this wasn't a function. But we know it's a function. I told you it was a function. Not that you always believe what I tell you, but believe me when I say that we have a function here, f. So what we want is a piece of the red graph and a piece of the blue graph, and together they are going to pass the VLT. But what pieces do we want? Well, it would be helpful to know what the endpoints are for the two pieces. Let's look at the first rule here, y equals x squared, which is relevant for this subdomain up here. Technically, this is the subdomain. From -2 to 1, including the -2, but excluding the 1. Okay, so this subdomain has a left endpoint at -2 and a right endpoint at 1. So this piece of the graph, if we just graph this, we'll have an endpoint at x equals -2, a left endpoint, and an endpoint at x equals 1, a right endpoint. So for the, and I'll write down the rules here. This is for y equals, well, this is for f of x equals x squared. And this is for f of x equals x plus 1. And I'll circle them for emphasis.